Our next keynote speaker, Eduardo Escobar Rodriguez. Eduardo is an electrical and electronic engineer from the Universidad de Los Angeles, Colombia, with a master's degree in electronic engineering. Eduardo has more than 4 years of experience in data analytics and development of machine learning models with applications in academy, credit risk, and public sector. Currently, he works in the National Planning Department, a government entity where he leads the Data Science Unit, a team dedicated to developing analytics and data mining projects to support public decision-making in different sectors such as health, education, justice, and public investment, among others. Please give it up a huge welcome to Eduardo Escobar.
Okay, so thank you for the invitation. I am here to speak a little bit about the work that we are doing in Colombia from a governmental perspective. So I'm going to first introduce a little bit the team, how was it created and what is it doing. And then I want to show three projects. That we have been working on in the past 8 months that we find very interesting and that we hope have a positive impact in the country. So first I want to give a quick overview, a quick description of what is it where I work and what is this team about. So first, the National Planning Department is a central Colombian entity, governmental entity. It is in charge mainly of 3 tasks. The first one is to manage the investment budget of the nation. So everything that is for investment projects, this entity assigns the funding and decides where it is spent. Is also in charge of making public policies, so that's a very important task, and also gives technical advice to other entities in the nation, such as ministries and governors and territorial entities. So a little bit of how this team was created and how I ended up here. So it all goes back to 2014. In Colombia, each 4 years we have what's called a National Development Plan. That is kind of the route that each president is going to follow in its period. So in the National Development Plan of 2014 to 2018, it was assigned to the National Planning Department the responsibility of designing the data exploitation policy for the state. How is the government going to take advantage of the data and to enforce the practice of data science inside the public sector? As part of this responsibility, on 2 years ago, on 2017, the data science team was created inside the entity. This was the first data science team in a public entity in Colombia. Right now there are at least 4 more, but this one, the first one established just with 4 people at the beginning. And then in last year, we released a Compass, is a public policy document, and this in particular the 3920, it gives the guide for exploiting data, for doing data analytics in the public sector. So it basically, it composes itself of 4 main elements. We think that we cannot do data science without data, so it is very important to ensure that there is digital data in good conditions to be taken advantage of. That's the input. The second item is to promote a data culture, and that is there is people with the power of taking decisions, and they need to know that a data science perspective and analytics perspective can give value to them. So they need to know how to ask for an analytics project. They need to demand these kind of projects. And the third one is the people who can do this. So training programs for people to learn these skills, to be able to do from simple data analysis to complex machine learning models. To all this range, we need people that has the skills for it. So what this document says is that if we can achieve these 3 points, then we can get to the goal that is a social and economic value for the country. This is from a public sector perspective, since the private sector kind of regulates itself in this kind of topics. The competence leads them to invest in this kind of developments. A little bit of demographic picture of the team right now. Right now we're 9 people, 6 staff and 3 interns. We have an interdisciplinary team in terms of the careers that the guys have studied. It is a relatively young team. The interns help in this one. And in terms of gender and precedence of the people, we could do better. Like right now, we only have 2 women on the team, and we are mostly people from Bogota, the capital. So that is something that we would like to get better, more diversity in these terms. We have worked with very different kinds of data. That is good. Like until last year, the team was in a process of making lots of quick pilot projects to show the potential of this. So we have made a lot of small projects. Right now we're going towards the direction of bigger projects with a deeper impact. That is the direction we are achieving. But we have worked with images, structured data, geographical data, text, and audio. We are just starting to work with audios. And text is the most commonly used type of data we have worked with, since we have many documents in digital format. And as I told you, the entity is transversal to all the sectors of the country. So we have worked in several fields, planning, justice, transportation, health. So right now, this was just the quick introduction. I want to share with you 3 projects that we like, that we have been working on. The first one is to apply machine learning for risk identification at projects financed with the general royalty system in Colombia. So a little bit about the general royalty system. It is a fund that was created with the money that the country gets for the exploitation of non-renewable natural resources, such as oil and carbon. So when the companies exploit these resources, they need to give a part to the government, and this fund was created to fund investment projects for all over the country. So since 2012, that's the start of this fund. More than 14,000 projects have been funded with more than $11 billion. So it is a big amount of money that we're talking here, and we're interested in keeping in good projects because, you know, in Latin American countries, corruption may happen, and we wish to reduce the risk of that. So when a project is proposed, it can be proposed by a mayor, by a governor, by other entities. It first goes to our entity, National Planning Department, and if it complies, it goes to another external board, and if it is approved, then it is contracted and executed. Right now, there is only information of the project itself when we do this, and we wanted to add information about all the projects before that to have a better informed selection process of the projects that we are going to give money to. So what we proposed at first, and I say at first because this approach changed on the fly, was to have an analytic model after the National Planning Department checks the viability. We would then analyze the information on that project, having all the projects in the past also, and decide if it will have difficulties or if it won't. So this would be like an additional filter in the whole process with more information. What information did we have to develop this? So the idea is to be able to score, to qualify a project in its early stage when it's just being formulated. So we had a small information about the project. We have like this text information that is where they may put the name, description, the objectives, what problems they wish to solve, what are the causes, the consequences. So this is all in a standard format that we had that text. We had some additional project of the information of the project, like where is it going to be, for how many years, how many money are they asking for, and what is it for, what sector. And as the target variable, we have some measurement that is given by the National Planning Department itself, and it's kind of a qualification that it gives to the projects according if they're going through according to the budget and the schedule or not. Some pre-processing needed to be made. Originally, we wanted to work just with the text, but the text provided no much predictive value to determine if the project is going to have difficulties or not. So that's why we incorporate the other two kinds of variables, what I told you, the time, the budget, the location, and the sector. So mainly, this is pretty standard. We found some very large budget values. They turn out to be wrongly typed. So we had to take some limits on these values. And then we tried with several definitions for the target variable. Mainly we wanted to define what it means to be a bad project or to be a good project. So we had this score, as I tell you, that is carried on by the SMSCE, that is the System of Monitoring and Following of Projects. And basically, what worked better was just a binary target variable that defined if a given project had required some corrective measurement, some corrective measure from this team of monitoring. And these corrective measures can be from just make an improvement plan, like the project is not going as expected, let's plan how to get out of this. And as the project gets worse, there are stronger measures until the project is suspended. So what we defined is if the project required any of this, it is qualified as a project that had difficulties. We had a sample of more than 12,000 projects, 80% per training, and some for testing that the model never saw. And then this was an interesting problem because, well, we had the text and we used an embedding. We used doc2vec that is based on neural networks to get a numerical representation of the text. But we did have like, I think it was 150 elements, this vector that the doc2vec was throwing. So we had this 150 vector and we have just a few categorical and numerical variables. We tried several things to work with both kind of data, because if we treat them all as equal, then the text was going to take all the credit, all the weight in the model. So after many trials, what worked better was after we have the numerical representation, we made some categories of the text that encaptured the topic and how they approached the causes and the problems. And this category entered as an extra variable for the final model. An XGBoost was the best performance we could get to predict if the model was going to have difficulties or not. So it worked well, but we didn't get very good results. We got around 80% accuracy. and we cannot deny a project with 80% accuracy. It was just not something that was politically viable to achieve. So our original idea of using this model for approval or disapproval of projects was dismissed. But we came around that, and we decided that we would use it as an score, not just a hard classificator as a good or bad, but a score. And this score would help to prioritize which projects are we going to monitor and follow more closely. Because as you saw, there are more than 13,000 projects right now, and the National Planning Department doesn't have the resources to travel to all of them and to be on top of all of them all the time. So we decided that we're going to establish some confidence ranges, and then that is going to help us decide which ones we should be more attention of. So the idea was we get a project, we pre-process, and we make the prediction, and this will give us a score between 0 and 1,000, where 1,000 is the model is the project is very reliable, we don't have to worry about it, and 0 is the project is most definitely is going to have problems. So here, the score itself is not the most important, but the range it falls into. We defined 8 ranges. And the idea is that you see as the score goes higher, the bad rate goes lower. So the worst range, which is the last one, has more than 50% of the projects in this range are going to have difficulties, whereas in the best range, just the 10% of the projects. So the idea is to give this information to decision makers and have them decide how many projects of each range are they going to visit and watch out for. We use the KS or Kolmogorov-Smirnov indicator just to tell the separation between the two distributions, the good projects and bad projects rate. So basically, it is like taking the width of this belly. The wider it is the better, because what we have here, we have the best models, and we have the worst models. We would like these two distributions to be as far of each other as possible. So that is what we measure with that indicator. 31 is a very good value, and it is good for this task of monitoring and following. Another project we worked on last year was to identify investment projects in Colombia that are working for the promotion of gender equality. So what is the problem here? That we have all these projects, right? That those are already approved. They are from all different sources of money. But we want to measure impact. We want to know if some policy is working, if we're achieving some objective or not. And Colombia is committed to the UN Sustainable Development Goals. There are 17 goals that ideally we should all achieve by 2030. So we want to achieve these goals, but we don't have a way to estimate the impact or to know if we're going good or going bad. So we wanted to get a way to quantify how many money are we investing in particular in this goal. This is one of the goals, gender equality. So we wanted to know how much money are we investing in it, which projects are working on it, and this is the first step to making an impact evaluation to see if it is working. This was done with text. This was text analysis, text mining, and we use public policy documents. So the idea was to use public policy documents about several different sectors in the economy and politics, and 3 public policy documents about gender equality. The idea was to compare these 2 corpuses. So we have the corpus of all the documents and the corpus of gender equality documents, and to identify which keywords are the ones that give more information about gender equality project. This can be, and that was the first part, the text mining part, and that was combined with an expert knowledge with the company of people who have studied and have background knowledge on gender equality. So we have the two corpuses, and we identified two kinds of groups of words. We have the exclusive words, so these are words that only appear on gender equality documents. And we have irrelevant words that appear on both corpuses, but we see that they have more weight and are more important in the gender equality document. So to define this relevant, we use three metrics. We use the difference. So we took the bag of words for the two corpuses and see the word frequency in gender equality versus the word frequency in other corpuses. We took the difference and we took the ratio, and we also took an approach to project the vector, this vector of bag of words, onto another space, and see the difference in that space and project it back. So it also gave us a good measurement of the importance, the relative importance of words between one corpus and another. So with these three matrix, we rank the words, and we pass these words to the experts on gender equality, and they tell us which of those works are important for the matter and which are irrelevant. Once we have this list, we define it 4 categories of words, and each category with different scoring. So this is an example. This is in Spanish because it is from an actual investment project. So we had like these different kinds of scores, where 15 points were the words that were the most relevant, and 3 points were the words that were somehow relevant, but not too much. So what we do is we take a look at the name, at the description, the objectives of each project, and if we find words that have a score attached to it, we just add it, and we get a single score for each project. These are the projects that get the most score. So if a project gets a higher score, it is more related to gender equality. This is all in Spanish, but you can see we have gender focus, women participation, women rights, and women matters. So at first sight, it looks right. We didn't have a way to define an exact score cut, to define a value where after this value it is a gender equality project, and before that value it is not. So we built an application in Shiny using R that allows to filter some according to the year, according to the source of funding, and to play with that threshold, to that score value that separates the gender equality projects from the ones that are not. So what we did with this was, again, go to the domain experts, ask them to look around, to play with this threshold, and they achieved a value that gave a good separation of projects. After we get that, we can quantify how much money are we investing per year or a total on these projects, and we can know exactly which ones they are. So as I told you, this is the first step to really know if it is working. We're still working on this project. We are currently extending this work to the remaining development goals. Gender equality is number 5, but we are going to extend it to all of them. Some of them are a little bit more difficult. And we want to depend less on domain-specific expert knowledge. We have been working on that. We have been taking different approaches. This is a problem that is multi-label also, because a one project can belong to more than one goal. So we have been looking at this. We have been trying to learn the criterion that the expert uses, but in an automatic way. And finally, this project is currently being developed, detection of settlements and buildings at risk of flooding. So the motivation is that flooding causes great damage in Colombia, and a great part of it is because of bad planning and bad urban design. So just last year, we have more than 54,000 people affected. Most 25% of the country, if we talk about states, and 20 municipalities or towns. And most of the victims are people that have low or no income, so they build their houses next to the rivers or next to big water bodies because that's where they can. And that shouldn't be allowed, but we are not doing anything about it. And we have outdated information by Colombia's Meteorology Institute. It goes back to 2010. So we really need better tools to identify what's happening in this regard. So the objective at first was to identify these buildings that have no kind of construction materials, of proper construction materials, of proper design, the ones that people build on their own. But we didn't have the image quality to do this. So we changed the approach to just get any building that is in the proximity of big water bodies. What we used, we need to use some GIS techniques to handle the information. This was done with satellite images and information from Google Street Map to know the location of water bodies. We have also a layer from the Meteorology Institute of Colombia, which shows the most dangerous parts of the country in terms of flooding. So we had to do some pre-processing of that, and we had to do some image processing for detecting the buildings itself. What we used, satellite imagery, we first used some images that were passed to us by the Geographical Institute, but the resolution they had was way too low for what we wanted to do. So we finally ended up using Google Maps API. That is the best we have right now. We hope to get better quality images. And some information, as I told you, about the rivers and about the risk of flooding events. This is currently on work. We decided to do the pilot on a town called Mocoa in Colombia. In 2017, Mocoa was a victim of a big tragedy. 3 rivers, they had a very great overflow, and the city just suffered a lot. And this became a national tragedy, and it shouldn't, because the weather was terrible, and climate change is worsening these kind of things. But most part of the responsibility was on the local authorities, that they didn't have a good plan to assess these kind of risks. So the numbers you see there, they really should have been much lower if we had done the things right. And that is what we want to achieve with this project, to help local authorities prepare better for this kind of events. This is a picture of Google Street Map, and this is the affected area. This is a better picture. This is a part of the city. You can see the mud covered streets completely, and part of houses. So it was really big, and it was really terrible. So we wanted to start with this town. So as I told you, didn't work the images we had. We went to Google Maps, and the first is to get them. Google Maps gives like a fixed size. So if we want bigger areas, we have to, it is like a puzzle. We have to put one by one. So we built that. Then we do some pre-processing, mainly taking away cloudy pixels, taking away the cloud, so we can have a brighter view of the city itself. We did a feature extraction, and at first we worked at a pixel level. So we work just with the RGB information of each pixel. We annotated manually some buildings. So the idea was to identify these buildings. And we also used some pre-existing datasets. So we found this dataset online that has also information about buildings. We combined both information to have more training data. But the results in this first approach were not very good. As you can see, like it gets the whole river as it was a building, and it gets many of the trees, many noise, many salt and pepper. We quantified this using the Jacquard index, that is mainly the intersection over the union between the prediction and the ground truth. And yeah, 58% is not great. So we took a second approach. Preprocessing remains the same. But now we used superpixels. So superpixels mainly, we group together groups of adjacent pixels. In this case, we use the HSV color space. So we made some histograms, and with this information, we group together groups of pixels. This approach has the great advantage that it is more efficient for both training and predicting, because we no longer have like thousands or millions of pixels, but we have just a few hundred superpixels. So it is all faster. The model was trained. We had to, again, to label each superpixel as having or not having a image, a building. But this model works a lot better. So you can see the original image on the left, and what the model classifies as buildings on the right. So sure, some of the buildings are still left out, but it is a much solid approach compared to the first one. We're looking at some image segmentation using deep learning techniques. The main difficulty for this is we don't have much data, so we need to gather some more data before trying some of this. This is another town, so we wanted to test on data that the model never saw. And it gives good results, like maybe this corner is not the best, but it gives good results. So what is the idea here? I'm going to step back a little bit. So we have this, let me go to the original. So we have this image, and we know where the water bodies are. We want to establish some safe zone around the water bodies, and in that zone, no building should be ever built because of the risk of flooding. So we want to detect how many buildings in different parts of the country are in this zone and plan ahead for next flooding events. And finally, I just want to take a step back. So as I told you, these are just 3 projects. We have worked on quite a few. And as I told you, we have the idea of getting in a deeper curve of getting projects that are bigger and have more impact, even if we get less projects a year. My personal diagnosis of the situation in Colombia at this moment is that we have room for improvement in all three elements that I talked about earlier. For example, digital data, especially in territorial entities, in entities that are not in Bogota but in other parts of the country, they manage everything in paper and they don't digitalize data still. They have bad practices of storing the data. We have been working with them to get it better because this is the input that we need for making meaningful projects. Data culture is still a challenge. People still don't have it clear about what can be done and what can't be done in a data science analytics project. So it is an education task that we need to do continuously. We go and present our work to different leaders and to different decision makers with the hope that they have a more clear image of what can be done. And because finally they are the ones that take the shots and they are the ones that can do the difference by giving support to these kinds of projects. And as for the skilled labor, we are not that bad in Colombia. Like we have two cities, Bogota and Medellin, that have a great amount of talent. In those cities, it is relatively easy to get the talent for these kinds of tasks. We want it to be the same in the remaining cities and towns in the country. So we have been working on a few projects that are not to solve a particular need, like the ones that I just showed you, but to facilitate this process. So we have been working a lot with text, especially in Spanish. You may all have encountered we don't have as much resources to do natural language processing as there are in English. So we are doing our library of text analysis to help this process, provided that we have worked a lot with that. And the other is that the government has the open data website, but people is not using it. So we are working as well so it becomes more accessible and people really start playing with the data sets that are up there. The idea, as I told you, is to create social and economic value. And yeah, that is what we were working on. Thank you very much.
Hi, thank you so much for your talk. I was wondering if you could speak a little bit as to what the general public thinks about using this kind of data. Do you have a lot of interactions with them? What do they like? Are there any concerns?
Thank you. In Colombia, people really like these kinds of topics. It is booming, as I think it is everywhere. They in Colombia are not as concerned about the ethical part yet of AI, but that is a discussion we should have as well. But yes, there are some issues related to what we saw in the launch talk, mainly about the explainability and interpretability of models. So for example, in the first project that I showed you, the one with the royalty system, at first they made a hard constraint that they wanted a model that was explainable, because they said no one would take the political cost of denying a project without being able to explain why they are denying a project. So yeah, we have to take into account explainability. But in general, it is very well accepted. Even some mandataries and some people use it more than they should because they really don't know what they're talking about. So there's also many speaking of the topic, but without really knowing it. But yeah, in general, it is accepted.
I have one more question. Is basically about you were saying the explainability thing. For example, in the project that you show you that you have some documents and you pick a classifier to make a score for each document. do you investigated what kind of features, word, or topics are making those documents, for example, to be ranked for the classifier, to have a high rank or high or lower score, and something more like the project 3 that you have a bunch of words and some words were more relevant than others?
Yeah, in that particular project, interpretability is easy because we actually have a domain expert helping us with the selection of the words. What we did from the analytics side was taking the documents and giving him a list of 100 words, so to automatically detect the ones that are candidates. And they chose with their domain knowledge. So that is a pretty basic one, and since we have the support, we can sort of explain it. We also have like the 3 metrics that I show you are like very clear. So if someone asks, we can just say that those are the criterion that we use. We are working on other ways to do this classification, so depending on the algorithm, it may become more difficult to explain. Yeah.
Thank you.
Okay, no?
Sorry.
Hi.
Hi.
Is the public value considered to measure the project, the whole project in Colombia?
What do you mean? Sorry.
The public value is something that people in Colombia could be considered valuable from the project of the government in Colombia. Is a qualitative measure, or could be a qualitative measure?
Yeah, it could be. I mean, like to have, it can have like several positive impacts. Just to raise the positive image that the people has in the government or in some institutions is already a winning. Our idea is that it goes way further. We are not very well known yet. As I told you, we are a very young team. So many people, when we speak about these topics, they all say, "Oh, we didn't know we have people working on that." But every time we know, yeah, we sense a positive impact, and in general, even if right now the government doesn't have a very good image amongst the people, but some entities like this one, like the National Planning Department, has always had a good image because of its technical focus. So it is not perceived as a political place for the people. So yeah, but the idea is to go everyone in the same direction. Okay. Thank you.